Hello dear friends. In last lecture, I will explain you how to differentiate the derivatives of the given functions in the exercise number 1.1. Okay. Today, I am going to teach you the exercise number 1.1 and question number 3. And from this question number 3, I will start from the question number 4. From question number 3, question number 4. Let us see here. Question number 4 is, what is y is equal to x cube minus 5u bracket raised to 5u divided by x cube plus 3 bracket cube. Okay. In last lecture, we have to understand how to differentiate the functions by using the rules of the differentiation. That is, sum of the two functions, product of the two functions, how to differentiate by using the rules of the differentiation, and by using the rules of differentiation simultaneously we use the standard formulae of the derivatives of the given functions. There are standard functions. In last lecture I have taught all the standard derivatives of the functions and formulas of the given formulas of the some functions, some standard functions, and what are the derivatives of that standard functions. That means power function, logarithmic function, exponential function, trigonometric functions, and what are the derivatives of that trigonometric functions, exponential functions. Okay. And in this example, this is of the format of u upon v. By using the rules of the differentiation of the quotient. By using the quotient rule. What is the quotient rule? This is of the type of y is equal to u upon v. And derivative of this u upon v is dy by dx. E is equal to. It is considered as numerator and denominator. Okay. And keep the denominator as it is and take the derivative of the numerator, that is du by dx, minus keep the numerator u as it is and take the derivative of the denominator dv by dx as it is and divided by v square. By using this formula, that is quotient rule, for this example. Okay. We solve the differentiation of this given function. Okay. Let us see how to differentiate. Students, you first practice the standard formulas of the derivatives of the given functions. Let us take question number 3, and from this question number 3 we have to take the fourth example, that is y is equal to x cube minus 5 divided by x cube minus 5 bracket raised to 5 and divided by x cube plus 3 bracket raised to 3. This is the function of the type u upon v. Okay. Then differentiate with respect to x. Differentiate y with respect to x. Then we get the differentiation of this given function is, that is y is equal to this, that is dy by dx, using the formula for the quotient rule. For this function we get x cube plus 3, that is the denominator, keep as it is, x cube plus 3 bracket raised to 3. Take the derivative of the numerator. What is the derivative of the numerator? That is x cube minus 5 bracket raised to 5. Minus. Okay. Minus. Keep the numerator as it is. that is x cube minus 5 bracket raised to 5 and take the derivative of the denominator that is x cube plus 3 bracket cube divided by denominator square that is x cube plus 3 cube and square of this. Okay, this becomes x cube plus 3 bracket cube as it is. X cube plus 3 bracket cube as it is. Take the derivative of this function. This is of the type of x raised to n. And what is x raised to n? Formula for x raised to n, that is the power function, becomes n into x raised to n minus 1. Using this formula for this. This is 5 into x cube minus 5 bracket raised to 4. That is, this 5 becomes here x cube minus 5 bracket raised to 5 minus 1 is 4 minus this, into take the derivative of the inside function it is like as a composite function. Taking the derivative directly also, and we have to write it as dy dx of x cube minus 5. Okay, as it is. Then take the derivative in the next step. Minus x cube minus 5 bracket raised to 5. The derivative of this is 3 into, by using x raised to n formula, that is n into x raised to n minus 1. Therefore, it becomes 3 into x cube plus 3 bracket square. Raised to n minus 1 means 3 minus 1. 3 minus 1 becomes 2 divided by x cube plus 3 bracket raised to 3 into 2 is a 6 and x becomes 6. And take the derivative of this again, that is d by dx of, what is the derivative? Multiply with the derivative of the inner side function, that is x cube plus 3. This becomes x cube plus 3 bracket cube into 5 into x cube minus 5 bracket raised to 4 into x cube minus 5. Derivative of this first is 3x square minus 5, that is the constant function. Derivative of the constant function is 0. Therefore, it becomes 3x square minus x cube minus 5 bracket raised to 5 into 3 as it is. X cube plus 3 bracket square also as it is, and into the derivative of x cube plus 3 multiplied by this, that is x cube. Derivative of x cube is 3x square and plus 3, it is a constant, therefore derivative of that is 0 divided by this. Keep as it is, that is x cube plus 3 bracket raised to 6. Clear, students? Then I am simplifying up to whenever we stop the simplification. Okay. Simplify till it becomes not simplified. Okay. When it becomes x cube plus 3 bracket cube, keep as it is, dy by dx is equal to x cube plus 3 bracket cube into 5 into 3 is 15. This becomes 15. 5 into 3, that is becomes 15 x square. X square, keep as it is, and x cube minus 5 bracket raised to 4. X cube minus 5 bracket raised to 4. And minus this minus sign, 3 into 3 is 9x square. This 3 and this 3. That is 9 and this is x square. This 9x square. Next, lower index term is x cube plus 3 bracket square x cube minus 5 bracket raised to 5. X cube minus 5 bracket raised to 5 divided by x cube plus 3 bracket raised to 6. X cube plus 3 bracket raised to 6. This dy by dx is equal to, this is 15x square. 15x square. Then x cube plus 3 bracket cube and x cube minus 5 bracket raised to 4. This is minus 9x square. X cube plus 3 bracket square. X cube minus 5 bracket raised to 5 divided by this x cube plus 3 bracket raised to 6. I am continuing this example. First, understand or not. Take it easy, very easy, and simplify it. Okay, I am going to the next step. Then whatever be common from these two terms, we have to take common from these two terms. 15x square and 9x square. From these two, we can take common. What common? This is in the table of 3. Okay, 3 5s are and 3 3s are 9. Therefore, 3x square take common from this. 3x square. X cube plus 3 bracket cube. X cube plus 3 bracket square. Therefore, we can take the common factor x cube plus 3 bracket square. One bracket is remaining here. And from these two, again x cube minus 5 bracket raised to 4 common. Then here remaining term 15, from 15 we have to take 3, that is 3 5s are, then 5 remaining as it is, that is 5 into this x cube plus 3 and minus 3, because from this 9 we have to take common 3, here remaining is 3 and x cube plus x cube minus 5 raised to 1, because raised to 4 we have to take common and raised to this 3, from this we have to take x cube plus 3 bracket square, therefore 1 bracket is remaining, raised to 1 here and raised to from here 1. Okay, and divided by this x cube plus 3 bracket raised to 6. Okay, that is equal to 3x square, and from these two we have to cancel this x cube minus 5 bracket raised to 4. This x cube plus 3 raised to 2 take to the denominator, because the base of these two is same. Then from the indices we have to subtract 6 minus 2, then it becomes 4. Then for this we have to multiply by 5, x cube plus 15 minus 3x cube, this minus minus becomes plus 15. This also becomes x cube plus 3 bracket raised to 4, because 6 minus this 2 becomes raised to 4. This becomes 5x cube minus 3x cube, that is 2x cube, plus 15 becomes plus 30. From these two, I have to directly take out the factor 2 common from this, and this becomes 6x square. From these two, we have to take 2 common. Then 3 into 2 is 6 x square. This is becomes x cube minus 5 bracket raised to 4. This becomes 5x cube minus 3x cube, that is 2x cubes. From this 2x cube we have to take common here 2. This becomes only x cube there. Okay. Plus 15 that is plus 30. From this plus 30 we have to take 2 common from this, that is becomes 6. Okay. This from this 2 we have to take 2 common, therefore 3 into 2 is a 6 and x cube plus 15 divided by x cube plus 3 bracket raised to 4. This is dy by dx. This is the final answer. Simplify up to we have to simplify. Whenever there is not simplified is possible, simplification is not possible, then we stop, and that is the final answer of the derivative of the function. Okay students, you have to study or practice of the standard formulas of the derivatives, and you have to use the rules for different types of examples by practicing. Okay, then only you can do it. This is very bigger, larger topic of the 12th syllabus, that is differentiation, and big exercises. From this there are 24 examples in the question number 3 and question number 2. Also we have to take many more examples in this exercise. Okay, let us take down next example. Let us next example is y is equal to next example is y is equal to 1 plus sin square x bracket square into 1 plus cos square x bracket raised to 3. Then for this example we have to use the formula, that is product rule for the differentiation of the functions. Product rule, that is u into v formula we are using for this example. U is the first bracket and v is the second bracket. And what is u into v formula? It is y is equal to u into v dy by dx is equal to u dv by dx plus v. Keep as it is and take the derivative of the first function again. First function you keep as it is, take the derivative of the second function, plus v keep as it is means the second function keep as it is, take the derivative of the this first function u du by dx. Okay, we have to use this formula for this. Okay, let us take first bracket as u, then differentiate y with respect to x. We get dy by dx is equal to, this is suppose you keep as it is, that is 1 plus sin square of x bracket square into derivative of the second function is this 1 plus cos square of x bracket cube plus keep the second function, that is 1 plus cos square of x cube as it is, and take the derivative d by dx of this 1 plus sin square x bracket square. Taking the derivatives, that is 1 plus sin square x bracket square into the derivative of this is by using the x raised to n formula 3 here and 1 plus cos square x raised to 2. I am taking the derivative of this inside function directly, that is derivative of the first function, that is 1 is 0, and the second function is cos square x, derivative of 2 cos square x is 2 cos x into minus of sin of x. Derivative of cos is minus of sin of x. Then plus next term is 1 plus cos square of x bracket cube. Derivative of this is 2 into 1 plus sin square of x raised to 2 minus 1 is raised to 1. This 2 becomes here lower side and upper side 2 minus 1, that is 1. And multiply with the derivative of this inside function. I am using the direct, therefore we have don't write about the d by dx of this 1 plus cos square x. Okay, I am using the directly the derivatives of this inside function. This derivative of this function 1 is 0 and sin square x. What is derivative of sin square x? It is 2 sin x into this sin square x. Derivative of this is 2 sin x into derivative of this sin x into cos of x. Again, this is becomes as a function of function, is the composite functions, and we are in the last lecture we have to see that how to differentiate the composite function, that is function of function, that is equal to, so by simplifying this 3 into 2, that is 6, 3 into 2 is 6, and this is the minus sign, therefore minus of 6. This becomes, again we have to write this as also as like this is 3, keep as it is, and this minus 3, and 2 sin x into cos x becomes sin of 2x. We can also use the formula for the 2 sin x into cos x means sin of 2x, this 3 as it is, and this minus side here. Therefore, it becomes minus 3 sin of 2x. It becomes 1 plus cos square x bracket square into 1 plus sin square x bracket square. This is the first term. In the second term, we have to also write it as first plus 2. This is 2. I am written here 1 plus sin square x. 1 plus, sorry, this 2 sin x cos x becomes sin of 2x. Sin of 2x. I have taken the terms, these two brackets here into 1 plus sin square x as it is into the another bracket is here remaining, that is 1 plus cos square x bracket cube. 1 plus cos square x bracket cube. Okay. And from this first and second terms, we have to take common terms from this. Sin 2x common, sin of 2x common from these two. 1 plus cos square of x bracket square and here cube times bracket square. 1 plus cos square x bracket square common. 1 plus sin square x bracket square, 1 plus sin square x raised to 1. We have to take common 1 plus sin square x raised to 1 common, and the remaining terms from here is minus 3, 1 plus sin square x is 1 plus sin square x remaining term. And here what remains? This is 2 and this is 1 plus cos square of x. Okay, because we have to take 1 plus cos square x bracket square common from this, then becomes plus 2 into 1 plus cos square of x. This is the remaining term. In the last, we have to calculate minus 3 sin square x. Okay. This 2 1 plus cos square of x. We have to simplify this. Okay, students. We have to simplify the terms. That is equal to dy by dx is equal to this sine of 2x. Keep as it is into the second bracket 1 plus cos square of x bracket square 1 plus sin square x. Keep as it is and simplifying or multiplying by this we get minus of 3 sin square x plus 2 cos square of x. We have to also use the sin square x. For the sin square x we have to use 1 minus cos square x. This minus 3 and this plus 2 becomes minus 1. The sine of 2x 1 plus cos square of x bracket square 1 plus sin square of x and into the bracket is minus 3 and plus 2 becomes minus 1. This minus 3 keep as it is and 1 minus cos square x and plus 2 cos square x. Okay, this becomes sine of 2x 1 plus cos square x bracket square 1 plus sin square x bracket raised to 1 as it is and this minus 1 this minus 3 minus plus cos square x plus 2 cos square x. This is 3 cos x. That is equal to sine of 2x 1 plus cos square x bracket square 1 plus sin square x as it is. This minus 1 minus 3 minus of 4. 3 plus 2 is plus 5 cos square x. Rewrite this term as like that is equal to sine of 2x into 1 plus cos square x bracket square 1 plus sin square x as it is and this becomes 5 cos square x minus 4. Okay, students, you have take these examples and practice it very much and more practice we have to study for the differentiation for this chapter. So practice more and more examples to get the rules and to get the formulas for the differentiation. I have to give on to you the standard formulas and rules of the differentiation. We have to For the next lecture, go to through the another exercise and another examples of this chapter. Okay.